Pre-calculus on-ramps. This is something to do with movement along a polygonal path. So along this polygon path. And what I'm going to have to do is find the domain of each one of these little segments, then define the function in that segment. It's very easy to do that once you've found the domain. And then, and before I do that, I have to find the length of each segment. And then I have to make sure I know where x starts and where y starts, where x starts and y ends at each segment, because that's going to be important for finding the value of the function. So how do I find the length of each segment? Well, distance formula. This is 1, 3. I don't have my pen turned on. This is 1, 3. This is 0, 0. Remember, the distance is the square root of x2 minus x1 squared plus y2 minus y1 squared. So it's the square root of 1 minus 0, which is 1, squared is 1, plus 3 minus 0, which is 3, squared is 9. 1 plus 9 is 10, square root of that. So the first segment has a length of square root of 10. I'm calculating these first because then everything else will fall in place. This point is 2, 1. So what's the distance from 1, 3 to 2, 1? And keep in mind in this segment, the y, the shift in y, the change in y is going to be negative. But this is 1 minus 2 is minus 1. Squared is 1. 3 minus 1 is 2. Squared is 4. 4 plus 1 is 5. This is square root of 5. And this one just has a distance of 2. Okay, so now I can answer these questions. What value of s yields the coordinate 1, 3, the point 1, 3? Well, to get to point 1, 3 along this graph, I have to go a distance of square root of 10. What value of s yields the coordinate 3, 1? 3, 1 is right here. So I have to go square root of 10 plus square root of 5 plus 1 to get there. So this one is square root of 10 plus square root of 5 plus 1. X, when the distance traveled, is square root of 10. Well, that gets me to the point A. I've gone a distance of square root of 10. That's 1. What is the y value when I've traveled square root of 10 plus square root of 5? Square root of 10 plus square root of 5. The y value is 1. What's x of a distance of 2? Well, 2 is somewhere in here because square root of 10 is 3 point something. So this distance is more than 3. 2 is somewhere in there, maybe there, who knows. Excuse me. Well, wait a minute. Yeah, about 2/3 of the way, maybe a little bit less. So it's somewhere in there. So I'm going to take the total shift in x, which x changes by 1, divide it by the total distance, square root of 10, and multiply it by the s, whatever distance I've traveled there. Well, in this case, multiplied by 2. So this is going to be 2 over square root of 10. And you can multiply by square root of 10 over square root of 10 equals 2 square root of 10 over 10, which is 1 square root of 10 over 5. So square root of 10 over 5. However you want to write it, you can do it on your calculator and find a decimal. Y of 2.5, well again, it's somewhere in here because this is 3 point something. So y of 2.5 is going to be the total change in y, which is 3, divided by the total distance, times s, times 2.5. What's 3 times 2.5? 7.5 over square root of 10. You can turn that into a decimal or rationalize the denominator. I wouldn't leave the answer like that. I would put a decimal approximation, or that's 7.5 square root of 10, square root of 10 over 10 equals 75 square root of 10 over 100. 25 goes into 75 3 times. 25 goes in 104. 3 square root of 10 over 4. So that would be the exact answer there. Okay, now piecewise function. To get the piecewise function, first thing, find the domain of each segment, and that'll make it very easy to find the value of the functions. So the first segment the distance goes from 0 to square root of 10. So I'll put that in here, and then it's the same for both x and y. So 0 is less than or equal to s is less than or equal to square root of 10. And then over here I'll do my x, and here I'll write the y. And not t, I always put t, it's x of s and y of s. All right, the next segment goes from square root of 10 to square root of 10 plus square root of 5. So square root of 10, whoops, I need more room. square root of 10 is less than or equal to s is less than or equal to square root of 10 plus square root of 5. Okay? Oh, this last part shouldn't be less than or equal to. That should just be less than. This is just less than. Why don't you tell me about this? That should just be less than. Third segment goes from square root of 10 plus square root of 5 less than or equal to s, less than or equal to, what's the final value? Square root of 10 plus square root of 5 plus 2. That's the total distance traveled to get to the end. Square root of 10 plus square root of 5 plus 2. Okay. Now, to write the value of the function, the x value of the function, I'm going to take the x value when I started and add it at the end. Well, in this case, it's plus 0. I will take the final value of the x function, which in this case is 1. To get to the end of that segment is just 1, so it's 1 divided by, what's the distance or length? Square root of 10. Times, it's going to be times s minus whatever came before. Well, nothing came before, so times s. In other words, s minus the left-hand constraint there. And that's for x. What about the y of s? For the y of s, it goes from 1 to 3, so it's 3. Y changes by 3 over square root of 10 times s. All right, I've got those. How about the next one? This time it's going to be s minus square root of 10 times, how much does x change in the second segment? It changes by 1. What's the distance of the second segment? Square root of 5. Where did x start? At the start of the second segment, x started at 1. So this is plus 1. Now this one, keep in mind, it's minus. And how much did y change? Or where did y start, rather? Y started at 3. So at the end, it's going to be plus 3. Okay. How much does y change? Y changes by 2. Divided by, what's the distance? Square root of 5. Times s minus square root of 10. S minus the left-hand constraint. And I'll show you in the... Now, they don't rationalize the denominators, and I'll prove that to you in the little answer sheet here for the x. See, it's 3 minus s minus 10 times 2 square root of 5. So, I just put the negative 2 over square root of 5 at the beginning. They don't rationalize it. All right, what about the third part? Well, for y, it's easy. The y of the third segment, the whole way across, y is just equal to 1. So the y part is easy. What about the x part? It's going to be, first I have to add where x started. X started at 2. I'm going to do s minus square root of 10 plus square root of 5, the quantity, so it's s minus square root of 10 minus square root of 5. And I'm going to multiply that by something. How much does the x change? The x changes by 2. And what's the distance it travels? 2, so that's just 1. That term just drops out, basically. So it's s minus square root of 10 minus square root of 5 plus 2 for x. And in the third segment, the y value is just, or y of s is just 1. And let's see if that's exactly how they wrote it. S minus, well, they left it inside the quantity. They said s minus square root of 10 plus square root of 5, which I can just distribute this negative sign and get what I wrote there. And then plus 2, always add where it started from. So that's how to answer this question, number 3, when I am, whatever this worksheet is again, doing movement along a polygonal path, or polygonal, however you want to say that.